Okay, we're going to be looking at homework 4.5.2 today, which is about double angles. So if you'll find that in your homework section. And then also on the UT website on Canvas, there's a good list of all of these formulas that I would highly recommend that you find. Today we're going to be working with these down here called the double angle identities. That's what we're going to be working with. On mine it's page 28. So if you need to pause the video for just a minute and find those 2 pages, that's where we're going to be going today. All right, I'm going to write on another sheet of paper just because my handwriting is kind of big. So starting here with number 1, when we work with double angle identities, I'm going to work on a triangle. Okay, so we don't use angles as much as we use triangles with these double angles. And they've told me that to draw my triangle, that the sine of what they're going to call x instead of theta, but you could change that into a theta if you wanted to, is the value of 1/4, and that we're working with this triangle in quadrant number 1. Okay, so let me take just a minute to draw that first. So my triangle is going to be in quadrant 1, and when I draw a triangle in quadrant 1, I'm going to make sure that x is on x and y is not on y, and theta is right here at my origin, so just like we've been drawing triangles. All right, and by giving me sine, they've given me my opposite over my hypotenuse. So I'm going to say that my hypotenuse is across from my right angle, so this is going to be 4. And my opposite side, so opposite from theta, is going to be right over here. That's going to be 1. And the first thing I'm going to do is find my missing side right here. So to find my missing side, I'm going to use Pythagorean theorem. So that's going to be legs squared plus, I'm going to go ahead and call this x. X squared, sorry, my side down here is x, and then is equal to my hypotenuse squared. All right, so a little quick math on that gives me that x squared is equal to 15, so x is going to be the square root of 15 right here. And sometimes if you're working in a different quadrant, be careful because your x or your y value may need to be negative, so be very careful with that. Okay, so my triangle is set up the way that I need it to set up, and I'm going to start with part A, finding the double angle value for sine. So if you look over here at your formulas for sine, they write them in theta. We're working with x's. It means the same thing. And my double angle formula for sine right here is 2 times sine theta times cosine theta. So let me go ahead and write that out with x's. That'll be 2 sine x cosine x. Okay, so I'm going to keep my 2, and then I'm going to fill in for my triangle sine x and cosine x. All right, so sine is going to be my opposite over my hypotenuse, and that was actually given to us in our formula, in our problem there, so opposite over hypotenuse. And cosine is going to be my adjacent over my hypotenuse. And then I'm just going to multiply top times top times top, which gives me 2 square roots of 15, and bottom times bottom times bottom, which gives me 16, and I can reduce that into the square root of 15 over 8. Okay, with my double angle for cosine, I actually have 3 formulas to choose from on this. So with my double angle for cosines, I can use this one or this one or this one, and I really like this one right here. So unless you're doing something where you need the other ones, I think this one's really good right here. So I'm going to use 2 cosine squared minus 1. All right, so let's fill in some information here. I'm going to put in my cosine value and square it, and then subtract 1. So my cosine from my triangle is going to be my adjacent over my hypotenuse. So my adjacent over my hypotenuse. So that's going to give me 2 times, when I square the square root of 15, I get 15, and when I square 4, I get 16. Minus 1, and then right here I'm going to do top times top and bottom times bottom. I could actually go ahead and do some cross cancel on this as well. So let's make that 15 over 8, and I'm going to go ahead and change this 1 into 8 over 8 so that I have a common denominator, which will give me 7 over 8. Okay, and then finally with tangent, so part C on number 1, the tangent of 2x, or 2 theta. My formula from my sheet is 2 times tangent x over 1 minus tangent squared. Okay, this one's a little bit weird because we're working with a square root. I'm going to jump right down here and I'm going to say that's 2 times tangent, which tangent is going to be my opposite over my adjacent. So that's going to give me 1 over the square root of 15. And then on the bottom, I'm going to have 1 minus 1 over the square root of 15 squared. Okay, so 2 times tangent over 1 minus tangent squared. All right, so again, right here, top times top is going to give me 2 over the square root of 15. And on the bottom, I'm going to hold on to that 1 just for a minute. I'm going to say this is minus. And when I square this, I'm going to have 1 over, and the square root of 15 squared gives me 15. So I'm going to change that 1 into 15 over 15 so that I have a common denominator. So I changed my 1 into 15 over 15 minus, and then I squared that to give me this piece over here. All right, the other thing I'm going to do just to make my life a little bit easier in just a minute, you'll see why in just a few seconds, is I'm going to go ahead and rationalize this denominator. So I'm going to multiply this by the square root of 15 over the square root of 15, which is going to give me 2 square roots of 15 over 15. And on the bottom, I'm going to have 14 over 15. And now I'm going to use keep it, change it, and flip it. And this is why I went ahead and rationalized that denominator, because now my 15s will cancel out. And that's going to start off giving me 2 square roots of 15 over 14, which will reduce down to the square root of 15 over 7. Okay, so that's how we find a double angle on each one of those using our triangle. Okay, all right, let's jump down and take a look at number 3. So numbers 3 through 6, what they're wanting you to do here is match up which formula you're using. So for example, on number 3, I've got cosine squared minus sine squared. So here we are right here, cosine squared minus sine squared gives me the double angle for cosine. So this is going to be equal to the cosine of 2 times this angle, so 22.5, and so that will give me the cosine of 45 degrees. Okay, this one would match up with sine. This one would also match up with cosine. Let's jump down here to this one. This one's going to match up with tangent. So really what I have here is the tangent of 2 times 75 degrees. And so that's going to give me the tangent of 150 degrees. Okay, so on 3 through 6, that's all they're getting you to do is just match up which formula are you using and then find that double angle. Okay, really similar on 7 through 10. So 7 through 10, I'm working again cosine squared and sine squared. So that's going to match up with my cosine double angle. So this is going to be cosine of 2 times 9x. And so that would give you the cosine of 18x. So really these down here are the same thing that you were doing on 3 through 6. It's just that you're working with an x value instead of a degree angle. That's the only difference there. Okay. All right, let's look over on the back side. These get a little bit harder because we're trying to solve some equations here. So I'm going to start with this one on number 12. Right, so on number 12, you've got some choices here. You could change into terms of your double angle. Well, let's just change into terms of our double angle for sine. Okay, so I'm sorry, I was thinking about a cosine. Cosine, you have some options. Sine, you do not. Okay, so I'm going to change this into my formula for sine. So that's 2 sine t. Let me take the parentheses back off of that. I'm just going to write t times cosine t. Okay, so if you match that up, the sine of 2t would be equal to 2 sine t cosine t. All right, and then that's going to be plus 3, sorry, square root of 3, cosine t is equal to 0. Okay, so I'm going to solve this equation. So if I'm looking at it, I notice that they both have a cosine t in common. I'm going to take that out like a common factor. So that's going to leave me with 2 sine t plus the square root of 3 is equal to 0. I'm running out of space. Let me jump over here to a sheet of paper real quick. Alright, so now I can take both of those pieces and I can set them equal to 0. So I can say that cosine t is equal to 0 and 2 sine t plus the square root of 3 is equal to 0. Okay, so with this one, if I'm thinking about my unit circle, I know that cosine is going to be equal to 0 right up here. So I'm going to say that that's where t is equal to pi over 2. And let's see if they want me to do all solutions. Let me read my directions here real quick. No, we're just working with solutions between 0 and 2 pi. So between 0 and 2 pi, that would be at pi over 2, and down here at 3 pi over 2. Okay, then this one, I'm going to have that sine t is equal to, subtract over my square root of 3, so negative square root of 3 over 2. All right, I know that sine is the square root of 3 over 2 up here at pi over 3. I want it to be negative, so using my all students take calculus, I'm going to be working in the third quadrant at 4 pi over 3, and in the fourth quadrant at 5 pi over 3. Okay, so because sine was negative, I went and I used values from the third and the fourth quadrants. Okay, again, somewhere back in your packet you should have one big unit circle that you can go and find these values on. Let me remind you that cosine is x and sine is y. Okay, 2 more. Let's take a look at 14. So 2 cosine squared x minus 2 cosine of 2x is equal to 1. Okay, and again, we've got some options on which formula you want to use with cosine. Again, I really like the 2 cosine squared minus 1. That one's my favorite, so I'm going to keep using that one. And so I'm going to take out where I have this cosine 2x right here, and I'm going to replace it with 2 cosine squared minus 1 is equal to 1. Okay, let me distribute a little bit there. Minus 4 cosine squared x plus 2, and I'm going to go ahead and subtract this 1 over also because we often need to have everything over onto one side together. Let's see what happens here. Alright, so this is going to give me, I've got 2 cosine squared minus 4 cosine squared gives me negative 2 cosine squared plus 1 is equal to 0. Alright, so let's move my 1. I'm going to subtract over my 1 and divide by negative 2 is going to give me 1/2. And then to get cosine by itself, I'm going to take the square root of both sides. And when I do that, be careful, I'm going to have a square root on both the top and the bottom, and I'm going to need my plus or minus. So what I start off with is that cosine is equal to plus or minus 1 over the square root of 2. Okay, so what I'm going to do is I'm going to split that up into cosine being equal to, and I'm going to rationalize this denominator, so that will be the positive square root of 2 over 2, and it will be negative square root of 2 over 2. Alright, so let me go back to my all students take calculus. So I know cosine is the square root of 2 over 2 at pi over 4, and in my fourth quadrant at 7 pi over 4, and it's going to be negative at 3 pi over 4 and 5 pi over 4. Again, if you haven't found that unit circle, go back in your notes from earlier this semester and find that unit circle so that you can find out what those values are. Okay, one more. Let's take a look at number 15. Last one. Look at number 15. Alright, I've got the sine of 2t is equal to cosine of t. All right, no options on sine. I'm going to have to replace that with 2 sine t cosine t, and then I'm going to subtract this cosine t over to this side. Again, we often want things to be on one side together. All right, I do have a common factor again, so I'm going to take out that common factor. That'll leave me with 2 sine t, and when I take a common factor of cosine out, I'm going to be left with 1 right there. All right, so both of those equal to 0. This one's kind of turning out very similar to another one that we did. All right, so this one, we said earlier, cosine 0 at pi over 2 and 3 pi over 2. So there's 2 answers. And then over here, I'm going to say that sine t, I'm going to add over my 1 and divide by my 2. All right, so sine is going to be 1/2 at pi over 6. Let me get that angle drawn right here. Pi over 6 is the square root of 3 over 2 and 1/2. So at pi over 6, and then I know sine is also positive. All students take calculus in the second quadrant, so that will be at 5 pi over 6. Very good. Okay, so your assignment for today is 1 through 18, so finish up that 4.5.2b, and let me know if you have any questions. Have a great day.